Hi, this is Ms. Nickel, and I'm going to be showing you how to access the Bohr model practice worksheet that I just posted in Canvas. That's going to be due on Monday, October 12th at the end of the day. So anyway, I'm in my student version of Canvas here on my iPad, and it's looking different today. For some reason, it suddenly stopped opening in the Safari browser and started opening in the app, even when I go through Rapid Identity. So I don't know if any of you are having that problem. And also I've noticed that my homepage is not loading correctly now. I think just because the images are pretty big, so I'll have to take care of that. Anyway, we can still go to assignments though, that's working. And so the assignment I'm talking about is the Bohr model practice worksheet, where you're going to be filling in the different subatomic particles in those drawings of atoms. Okay, so but before we actually start on the assignment, I wanted to show you that I put another periodic table in here. And the good thing about that is that you can actually store that on your iPad. So I found this app called Books. I don't know if you guys are using that, and you can put it into Books. I already put it there, so I think it just went there and opened it up in Books. But if you just click on that up arrow in the upper right-hand corner of your screen, here in the upper right-hand corner of the screen, I guess I can't draw on that right now, you will be able to send it to Books, and then it will be stored there, and you can just keep that open anytime you're needing to work with the periodic table, and it'll be right there for you. Okay, so anyway, that's what it looks like in Books. You can just have that open. I'm going to go back into the assignment now, and here we go. Click on the Bohr model worksheet. Okay, and before I do that though, I just want to point out that the directions for the worksheet are right underneath the link for the worksheet. We're going to leave that open and be coming back to it. Okay, so this is going to go ahead and open up the PDF, and this is a PDF, so you can't write directly on it, and I don't want to write on it here in Canvas. What I want to do is click on that box in the upper right hand corner again with the up arrow, click on Notability, and I'm going to send it to Notability. So here I can say create new note, and it says this is the Bohr model worksheet, and so I'm going to go ahead and import that, and it's done. Okay, so now it's going to be in Notability, but first I'm just going to go back to those directions here in Canvas and also have that open. So if I go into Notability, then I have to get the app open on my iPad right here. And so here's Notability, and I have a list of different notes that I have in there. This is at the top of the list. And this is what your worksheet looks like. So you have a place to put in all the different information about the atomic structure, and then you're actually going to draw the atom on that skeleton that I put into the page. All right, so the one that I want you guys to do right now is actually a different one. Here it is. Well, you have the one I was showing you, but I want to do an example. So I'm going to do boron, which you don't have right now. Okay, so let's see. First thing we're going to do is we're going to fill in the information about atomic number and mass, and then figure out what all our particle numbers are. And that's pretty straightforward because we already have the cell for boron down here in the corner. So I'm going to circle the atomic number right here. And usually that's at the top and it's a whole number. So the atomic number is 5. And then I'm also going to circle the atomic mass down below. Here's your atomic mass, which is 10.8. So that's atomic mass. I'm going to round it to 11 because we always make that a whole number. Remember, that is an average of the different isotopes of boron. That's why it's not a whole number. And it's also the protons and the neutrons together because that's what makes up the nucleus. So then we can start to put in the different numbers over here. And I forgot to fill in that atomic number. So let me go back and do that. There's the atomic number. That is a 5. Okay, so we've got 5 protons, atomic mass of 11. We'll go ahead and write in the protons, then 2, 5 here, and the electrons are going to be the same as the protons because we have to have the positive and negative charge balanced in a neutral atom. And so the only thing I have left then to do is to figure out my neutrons. And let's see, you can do that in your head, I'm sure, but I'm going to go ahead and write it out. So that's going to be the atomic mass minus the number of protons. I like using color. Okay, and then let's see, we'll set that equal to, and that's going to end up being 6. And I usually do neutrons in green. Okay, right there. All right, so our number of neutrons is going to be 6. Now I want to write those particles in the nucleus, so I'm going to put the neutrons as a 6 right there. I'm going to put the protons as a 5. We're just using numbers now. We're not going to be writing or drawing all the different particles anymore. And then I get to move to my electrons, which is the fun part. So my electrons, I have a total of 5 electrons. And so, oh, I forgot though, on your guys' worksheet, you have something in the upper right-hand corner there to put in the energy levels because we have to know that. I won't always be drawing those in for you. So the way we figure out what energy, how many energy levels boron has, if I didn't already have them drawn here, would be to go here and look at the periodic table that I had open in that books app. And I'm going to take a screenshot of that so that I can write on it. And so we're going to look for boron. It's element number 5. So there it is in the second row or period on the periodic table. So when you're talking about periods, you've got the numbers right here on the side, 1, 2, 3, 4, 5, 6, and 7, okay? First period only has 2 elements in it. That's why you only put 2 electrons in the first shell. After that, you'll have 8, 1, 2, 3. See, boron has 3 in the second period, plus the 2 from the first, so a total of 5. But this entire shell could hold up to 8. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay? All right, so we know we have 2 energy shells for boron. Let me get rid of the screenshot and we'll go back to the worksheet. Okay, so then we're going to start putting in those electrons. Like I said, just 2 in the first shell. Oh, and we were going to write that in for you guys. That's right. Okay. All right, so up here, your period would equal 2, and your energy level would be the same as the period, okay? I just put both in to make that clear, that the 2 are the same thing. All right, now we can put in the electrons. Okay, here we go. We're going to put 2 electrons in the first shell. We have a total of 5 to get rid of, and the 2 in the first shell are always paired. If you didn't remember what to do, you could go back here to the directions for the worksheet, and you'll see that right here. So right here I say start filling from the inside out. You have 2 electrons in the first shell, all right, and that they are paired. And then you have 8 electrons in every shell after that, and you don't start pairing until after 4, okay? So put the first 4 in unpaired. All right, get rid of that. And go back here. We had put in 2 electrons in that first shell. And so now I'll start putting the electrons in the second shell, which is the outer shell here. As long as I don't pair them until after 4, honestly, it doesn't matter where you put them. I like to put it kind of symmetrically, but as long as they're in the right shell and the pairing is right, I'm happy. Okay, so that is everything you needed to do your Bohr model of boron, and then you would just move on to the next one, which in this worksheet is nitrogen, but you guys have something different.